Hi, this is Bill Punch, another video in Michigan State University's Introduction to Computer Science using Python, CSE 231. For this video, we're going to talk about the algorithm and approach for doing string comparisons. Let's go ahead and get started. We haven't really talked about string comparisons yet. String comparisons are a little complicated because we need to have a way to represent each character in a string, and it turns out there are many, and more importantly, it turns out that English is not the only language in the world. There are many languages that have very special characters that we would also like to represent. In the old days, there was a representation of only the English characters. This has been expanded to represent all characters, and it's called the Unicode representation. There's a particular Unicode called UTF-8 that represents the English characters as well as other characters. If you go to a web page and try to find some of these guys, you can find a representation. And here is a web page on what was called the ASCII character code, but the ASCII character code is the same as UTF. And here's a table. And you'll see that for every one of these, let's go down a ways. For every element, there's a number associated with it. So for the character 0, that has a decimal value of 48. For the character 9, that has a decimal value of 57. For the uppercase character P, that has a decimal value of 80. For the lowercase letter m, that has a decimal number of 109. So every character in this table has an associated numeric integer, and it's these numeric integers that allow us to do comparisons between characters. We'll come back to that. So as I said, if you look at that table, the numbers range from, in the table, 48 to 57, the lowercase letters from 97 to 122, the uppercase letters from 65 to 90. And they come in the order you expect, and so for 0, it's the lowest value, followed by 1, followed by 2. For lowercase letters, A comes first, followed by V, so on and so forth. So within those sequences, lowercase, uppercase, and numbers, you get the ordering that you would expect. We can use the index that they have in this table to make a comparison. So if we compare individual characters, we can say, is the character A less than the character B? And the way Python will make that comparison is to look up the table, their numeric values, and see if the number is smaller than the other. So for each one of these, is A less than B, is 0 less than 1, is capital A less than capital B. Those are all going to be true because in the order of the table, lowercase a has a smaller number associated with it than lowercase b. The character 0 has a smaller number associated than 1. Capital A has a smaller number associated instead of B. It can get a little weird when you compare outside of your sequence, and so how do you compare big A and little a? How do you compare the number 1 and the character A? It's not always clear, right? It turns out that A, the capital A, is actually smaller than little a in terms of those numbers in the table. It turns out the number 1 is smaller than little case a. So what you really should take away from this is that comparison should occur sort of in your sequence. So the lowercase letters, the uppercase letters, or the characters that represents numbers, that's the way it should work. So we can compare individual characters. Now how do we do string comparisons? And that actually turns out to pretty straightforward. We have a little algorithm that helps us do it. And here's the algorithm. We compare the first character, index 0, of each string. So we're comparing two strings. If those characters are the same, then we move on to the next two characters at index 1 and compare those two characters. So index by index between these two strings, we're comparing characters, and we do it until we come to a difference. When the difference is found, it's the comparison of the two characters of the difference that determines the comparison of the string. And then as sort of an edge case, if one string has exactly the same characters as the other but is shorter, the shorter string is smaller. So let's look at some examples. So we're looking at AABC versus AADC. So we do what we said. We compare the first character against the first character. Nope, those are the same. So we move on to the second character against the second character. Nope, those are the same. Keep going. We find the third character against the third character, and that is a difference. And so we're now really reducing this to the question, is little case b less than little case d? this is true, so the answer for the string altogether is true. Do it again for this case. Is little-case a different than little-case a? No, it's not, so we move on. Is little-case b different than little-case a? It is. So the question is little-case b less than little-case a? Right, that's the answer for the string. This is false, so the answer for the string is going to be false. If by some chance we get a comparison of two strings where one is shorter than the other, so a is the same as a, second case a, same as a, third one a is the same as a, this is the shorter string. The shorter string is smaller. So is triple A less than quadruple A? It is.